Hello everyone, I am Soumyashree Senapati, Assistant Professor, Vedang Institute of Technology. So, we have already discussed stresses acting in uniaxial direction. Now, in this class, we will discuss stresses acting in biaxial direction, or you can say two direct stresses will apply at an object. So, we have taken already this object. Let's now, if we cut this in this direction. So, if we got this, we have this plane. Okay, let's name it as A, B, C and D. So, we have the object and as ABCD plane. So, we can name it also E. So, if we just separate this B, C, E, so we will have our BCE plane. So, also in this case, we have the Px here. This Px is nothing but our force. Okay. So, and the Py here. So, we know that there will be some normal stress. Let's name it as Pn. Right. So, we have here Px and Py. If here we have the angle, let's take this angle as theta. So, here we can have the angle that is 90 minus theta, right? So, due to this is theta, we have the angle here as theta. So, here I am having theta as the angle. Now, if we just draw the 3D section of this triangular section, let's so here. So, we know there will be some thickness of this object. Let's name that as T. Okay. Here we have what? Forces, that is Px and Py. Due to Px, as it is acting here in which plane? In BC plane. Due to Px, there will be stress. As we know, the formula for stress is nothing but our force upon area, right? So, we have the force here Px and Py. Due to this force P, we will know that stress P will be stress into area. Due to Px, the stresses arises, that will be nothing but sigma x, and due to Py, there will be stresses sigma y, right? So, here for Px we can write sigma x multiply with area. So, which area? Px is acting along BC plane. So, we can take area of BC, right? Area of BC. So, in BC plane, there will be one thing, that is thickness, and another thing, the length here. So, also we can write Px is equals to sigma x into what? Into BC into thickness T, right? Also, this thickness is T, and here we have EC. So, in Py we can write sigma y into EC into T. Okay. Now we have Px and Py. So, if we put this T, if we put this T as 1, let's take this T as unity and we can take it as 1. So, our Px will be nothing but sigma x into BC and Py will be sigma y multiply with EC. Okay. Now, so if we draw that diagram here, here we have Px and here we have Py and in this direction we have Pn. Okay. Okay. Now we can have, okay, still we have the angle theta here. So this will be theta, right? Okay. If we take the components of Px and Py, right? So here we have theta and here we have 90 minus theta. So if we just extend this will be, okay. So due to this is 90 minus theta, here we will have one theta and in this direction we will have 90 minus theta. So this will be also the theta. Okay. So due to this we will have the components of Py, that is Py cos theta and another one is Py sin theta, right? Also Px has two components, that is Px cos theta and here Px sin theta. Okay. Now we have four components, that is here we have Py cos theta and sin theta, Px cos theta and Px sin theta, right? So, okay, if we just extend this, right? So, in this direction, okay, here we can write Py cos theta. All okay. In this direction, we are having Py sin theta. So, it also will be our Py sin theta. Okay. Now, due to this Px, we are having here Px sin theta and along Pn, we are having one stress, that is Px cos theta. Okay. So, now we need to find out what? Sigma n is equals to what? Our biggest question is to find out normal stress. So, now we all have all those components. To find out sigma n, we need what? Pn and area. Easily we can find out these things. So, for Pn, we can write, okay, we can write components of Px and Py along Pn of an area. So, which area? Here. In this triangle, this is B, C and E. So let's name it as B, C and E. As we can see that Pn is acting at BE, right? So we will take the area of what? BE. So area of BE is nothing that, so this area will be what? This length multiply with the thickness. So area will be what? B into T, and we have already taken this T as unity. Okay, so we can write the components of Px and Py that we have already found out here. So in Pn we have one that is Px cos theta, and here that is Py sin theta along Pn. Okay, these are the components of these two. Py sin theta and Px cos theta are components along Pn. Okay, so we can write Py sin theta plus Px cos theta. Okay, and area of BE, so we can write BE into 1. Sigma n will be, so if we just simplify this, Py, so here we can put the value of Py and Px as we have already found out here. Here we have the values, this is the value. Px is equal to sigma x into Bc and Py is equal to sigma y into Ec. So we can write sigma n equals to sigma y into what? Sigma y into Be sin theta upon Pe. Here, as normal stress is acting in this plane, let's take Ce, right? So Ce plus sigma x into which plane? X is acting in this plane, that's why Pc cos theta upon Ce. So sigma n equals to B upon C base upon hypotenuse. We can write sigma y into sin square theta plus sigma x into what? BC, this upon this. This is our perpendicular upon hypotenuse. Will be cos square theta. So if we write it in form of cos 2 theta, so we will have sigma y into 1 minus cos 2 theta plus sigma x into 1 plus cos 2 theta, right, upon 2, and here also like this. So if we just resolve this, we will get the value of sigma n. So our sigma n will be, we can write sigma y upon 2 minus cos 2 theta upon 2 into sigma y. Here as written, if we just multiply this sigma y with this and this, we will have the value plus sigma x by 2 plus cos 2 theta multiply by sigma x divided by 2, right? So, sigma n will be sigma x by 2 minus sigma y by 2, sorry, plus minus sigma x plus sigma x cos 2 theta upon 2 minus sigma y into cos 2 theta upon 2, right? So, if we just beautify this equation, we will have sigma x plus sigma y by 2, and here if we just take the common as sigma 2 theta, we will have sigma x minus sigma y by 2. Okay. So, now we have the equation for normal stress. Here another equation is from here. We have the tangential stress like this. So, let's take the name as sigma T, right? Okay. So, this to find out this sigma T, okay, this will also acting in which plane? This EC plane. So, to find out tangential stress, that is sigma T, also you can name it as tau, right? So, our tau will be components of Px and Py along what? Along Pt, that is tangential force upon area of EC. So, we will have tau is equals to, here you can see from this, okay. So, tangential stress is acting like this. So, here we have one Px sin theta and we have Py cos theta along this, along direction Pt. Okay. So, let's take Px sin theta and Py cos theta. Okay. Here another thing, if this is acting in this direction and this is acting in this direction, so one will be positive and one will be negative, right? So, we have Px and let's take this as positive and this as negative. Sin theta minus Py cos theta divided with EC. So, this tau value will be, we already have Px and Py here. Px is nothing but sigma x in which direction? Sigma x, we can draw the triangle here PCE. So, this is our Px and this is our Py. So, this will be in BC. BC sin theta upon EC minus sigma y into Pe cos theta upon what? EC. Why I am drawing this section very frequently? Because all these informations are here only in this triangle. Okay. If we understand this diagram, right? Here, if we just understand this diagram, then there will be very easy to find out sigma n and tau. Okay. First we have find out the angles, then we have find out the components of forces. There is nothing big deal here. So BC upon EC. BC is what? Perpendicular upon hypotenuse. So tau will be sigma x into sin theta into cos theta minus sigma y into BE upon EC. B is our what? Base and hypotenuse. So this will be sigma y into sin theta into cos theta. Okay. Tau is equals to, if we just put this common, sin theta into cos theta sigma x minus sigma y. Let's just multiply and divide to here. So the tau value will be what? Tau will be 2 sin theta into cos theta is what? Nothing but sin 2 theta. Sin 2 theta, we can write sigma x minus sigma y upon 2. No issue here. So we have sigma n and tau value. Sigma x minus sigma y by 2 into sin 2 theta, and here sigma x plus sigma y by 2 plus, here we already have the values, sigma x minus sigma y by 2 into cos 2 theta. Okay. Now we have sigma n and tau value. Let's to find out the maximum shear stress. What will happen? Maximum shear stress. We know that tau is our what? Tau is our shear stress. So all the things depends upon the value of tau will be here, theta. So in our table, sin cos table, okay, if you are not remember, you have not remembered the values of sin 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Okay. Sin 0 is what? 0. Sin 30 is 1 by 2. Sin 45 is 1 by root 2. Sin 60 is root 3 upon 2. Sin 90 is 1. Okay. So this cycle will repeat after 90. Okay. So until now we just need this up to 90 degree. So sin 90 is 1. If we put the 2 theta as what? 90 degrees, so then our value will be maximum. So to become this theta as 90, we will have theta as 45 degree. So to find out maximum stress, shear stress, we will need theta as 45 degree. Okay. Also, here, also we know what? This plane will become principal plane when? If the shear stress acting here become what? 0. So if tau will be 0, then it will be our principal stress, and the sigma n termed as principal stress. Okay. So to make it principal plane. What do we need to do? We know that sine 0 equals to 0. If we got the object, the first object, here, this will be our some angle. If we got this theta will be 0, then this will be our principal plane. Okay. So, here we can write this is our maximum and theta is equals to 0, we will get minimum or 0 shear stress. Okay. So, in this class, we have the values of sigma n and tau at biaxial stresses, when in case of any plane there will be acting of two directional stresses. So, we have found out the value sigma n and tau here. So, till now, thank you so much.